Mustafa asked us, how do I interpret a p-value in plain English without overselling what my data shows or getting confused? So, Matthew, what's a p-value? Why do we use it? And how do we explain it without confusing everyone?
Yeah, here's the $1 million question, right? Man, we're starting strong today. So, p value, this is something that really throws a lot of graduate students, and I'm going to also say a lot of working professionals. There's a great article, you can Google and find this. 538 put out an article several years ago where they went to a stats conference and they asked statisticians to define a p value. They didn't get the same answer twice, and several people said, I don't really know. So if you're in that boat and you're feeling like, gosh, I don't really know what this means, you're in good company because it's one of those things that is just very esoteric. So, what is the p value? Putting it in plain language, p value helps us to understand how likely it is that the difference between two groups is due to random chance or due to whatever intervention may have been introduced into that mix. Intervention, difference, category, it could be a lot of things, right? So we have this sort of arbitrary number of 0.05, which is 5%. So we say, there's a 5% chance that this is due to just luck, just happenstance. Again, that is an arbitrary number. There are literally whole books written about the history of p value that discuss how the origins of that threshold came to be, but that is sort of the established value. And we're just going to go with it. We're not going to think too hard about it because it is a pretty arbitrary value. And then we also see that 0.001 or zero 0.01 and 0.001 as being sort of, again, your benchmarks of statistical significance. So if our p-value is below those measures, we say that the results are significantly different. So again, we're just trying to demonstrate that there is a difference. So we might look at the average, for example, of two groups so we can see with our eyes, there's a clear difference here. These numbers are different. The p-value helps us understand what is the likelihood that that difference is due to chance versus the actual intervention or situation we were in.
Just to follow up on that question, what do you think is the best way to present your results? Let's say we got that significant p-value. What do we need to say about that? Do we just say it's significant and carry on our way, or is there anything else that we need to be aware of?
So I think it's important that we consider both the statistical significance and practical significance of our results. My work as a professional is in the K-12 education space. And so I often will use examples in that setting. Something can be statistically significant, but the actual change or difference between groups can be very small. And so we want to be able to kind of apply that practical significance. Measures like effect size can be a great way for us to do that, to put that p-value in a little context. Again, I said earlier, there's whole books written about p-value and its history and the questions and the problems. There's also a pretty big movement in the statistics world to shift towards practical significance and kind of downplay that statistical significance a little. So anytime that we can wrap that p-value in some context with some other statistics like effect size is a good one. You can use correlation to do that as well. That's going to help that p-value make a little more sense to your reader, give you a little more credibility too.
That's a great point. We also see it a lot in the medical field where there is statistical significance, but the change in the incidence rate for a disease is absolutely minuscule. And so it's not a practical improvement as well.